Okay, good afternoon to all of you. I think in my previous session, we discussed that few fundamental things related to the DC circuit. Am I right? Uh, Let me try to revise the things what we discussed in the previous session, and then we proceed further. So I think in the previous session, we discussed that the first point, and that is nothing but what is mean by circuit. Is it right? So the circuit, we know that we regularly use this word in our daily discussion. So the circuit is nothing but we call it's a closed path through which current can flow. That closed path, we call it's a circuit. Am I right? Then within that closed path, maybe resistor, capacitor, that inductor, the transistor, or whatever it may be the component it may connected, but the circuit is nothing but a one closed path through which a current can flow. And after that, we discuss that the second point, which is nothing but the current. Am I right? Okay. This current, again, as if you try to read that the title of the title of the topic is our DC circuit. Out of that, the circuit means we know that. Now just give the more focus on what is meant by DC. Before that, just concentrate towards the word current. What is meant by that electric current? Actually, the current is of two types. One is AC current, another one is DC current. We call it a direct current and so let's try to give the more focus on the DC current because our topic name is a DC circuit. What is mean by what you know about that the direct current? Tell me first. Yes. Huh? Anything? What you know about that DC current? शब्द ऐकलाय? वाचलाय? Then tell me, whatever it may be wrong. त्याचा विचार करू नका. तुम्हाला जे माहिती आहे ते सांगा. Correct, I got it, your point. Got it. Okay, anything else? Yes, one direction कोणतरी म्हणताय. Very good. Anything else? मला वाटतं तुम्हाला थोडासा अजून अभ्यास व्यवस्थित करावा लागणार आहे. Let me try to explain because this is not the new part. Actually, I expect that the answer of this DC from your side, but no issue. I will try to explain. A current which has a constant magnitude in one direction, that current we call it a DC current. A current which has what? Constant magnitude in one direction, that current we call it's a direct current. When I want to draw the graph for the current, then definitely I can draw the graph for the direct current with respect to time t. Actually, on the x-axis we consider the time t. It's a constant. It means that a one horizontal line. So what this horizontal line indicates, it's a constant magnitude. It will not change with respect to time. Is it right? That's why we can define the direct current like that: 5 ampere, 10 ampere, 15 ampere, whatever it may be. Means what? Suppose we assume that a 5 ampere DC current, it means that the magnitude of that current is always constant in a one direction. That's why we can define the direct current is nothing but the current which has a constant magnitude in a one direction. And how you draw the graph, you can see on the slide here. It's a one horizontal line, and that line, it indicates that the current will not change its a value with respect to time. The value is always constant. Then the second type, if you take it, that alternating current, name itself gives that the meaning. Alternating means what? A current which will change its magnitude. Change its magnitude as well as direction. It means that the current which will change its magnitude as well as direction with respect to time. Every current we will try to define with respect to time. So don't forget that important word. The current which will change its magnitude as well as the direction, that current we call it a alternating current. And when I want to represent this alternating current through the graph or the waveform, then I can draw the alternating current with a sine waveform. Have you observed anywhere? Get it my point? So what this alternating sine waveform, it indicates, if you observe this sine waveform, the sine waveform having the two half cycle, one is a positive half cycle, another one is a negative half cycle. And now if you try to observe that, the value of alternating current, it going to be changed with respect to time, as well as the direction is also changed. This is the difference between the DC current and that AC current is there. Now, you might be aware that at the generation station, that electricity is generated in the form of alternating. It will be transmitted in the form of alternating. But as and when required, it is our duty, whenever it is required, we will convert alternating into the direct current. Because there are some instruments, just like a cell phone battery, there are some instruments which are nothing but the DC storage. For example, cell phone battery is a DC storage. When we want to charge our cell phone battery, it is necessary to convert that AC signal into the DC signal, and that part we call it's a rectifier. And what is that rectifier circuit? Definitely we will try to discuss in the fifth topic. But right now, you have to give the more focus on the direct current. Let me try to tell you, the direct current is always denoted with the capital letters I, and that alternating current is always denoted with the small letters I. This is the difference. So what you have to remember in the DC current and the AC current, the two things. Number one, direct current is denoted with capital I. Alternating current is denoted with a small I. Number two, the magnitude as well as direction of a direct current is always constant, and the magnitude and the direction of an alternating current is always changes with respect to time. Are you clear my point? Any doubt related to the DC and the AC? Now come to that, our title of the topic. Our title of the topic is DC circuit. Now I already explained what is meant by circuit, and just now I explained that what is meant by DC. Now both the things we have to combine. So this combination is nothing but the meaning of a DC circuit. Now how we define that the DC circuit, the title, what is the meaning of that title DC circuit? So we can explain like that: a closed path followed by direct current is called as a DC circuit. How you define? Once again, you please repeat along with me. What is meant by the circuit? It's a closed path. A closed path followed by direct current is called as DC circuit. म्हणजे काय की असा एक क्लोज्ड पाथ की ज्याच्यामधून कसला करंट फ्लो होतोय? डायरेक्ट करंट फ्लो होतोय, त्या सर्किटला आपण काय म्हणणार आहोत? DC circuit म्हणणार आहोत. This is the simple definition for the DC circuit is that. Is it that clear? Now, what are the essential things are required to prepare the DC circuit? अशा कोणत्या गोष्टी आहेत essential, I say that essential, through which we can prepare the DC circuit. So you can just observe here. So you can read that the definition, a closed path followed by the direct current is called as a DC circuit. Now there are total 3 essential things which are required to prepare the DC circuit. Number 1, energy source. Number 2, load resistance. Number 3, connecting wires. Now this is a DC circuit. If you observe that, you will observe that out of these 3 essential parts, the first part is what? DC energy source. So this is a DC energy source. Is it right? We call it applied voltage. Number 2 is a resistance. This is the resistance. And number 3 is the connecting wires. So these are the connecting wires are there. So this is a simple DC circuit. Is it that clear? Now, let me try to cover another one point. Now, please concentrate here. Suppose here I consider that one copper wire. Here I just consider that a one copper wire. So this is a copper wire. Do you know that the copper is a conductor? Okay. It means that every material, if you try to classify it electrically, then this material can be classified into 3 parts. One is conductor. Second one is insulator. And third one is semiconductor. I use the short form here. Okay. How you define that conductor? Means what? Very good. Any another thing? Free electrons? Free electrons म्हणून कसं भागेल? त्याच्या पुढे काहीतरी सांगा की. Okay. Don't go in that much depth for the physics. Let me repeat. Do you know that who will conduct the current? Basically, basic question here. Who will conduct the current? Valence electron or free electron? Confusion is there. Valence or free? Is the valence or are the valence electrons and the free electrons are same? Yes or no? Yes or no? No. What is meant by valence electron? The electrons which are present in the outermost shell or at the last orbit of an atomic structure, that electrons we call it a. Then what is meant by free electrons? Same? Not same. Electrons which are in a sharing. No. No. Let me explain. All free electrons are the valence electron, but all valence electrons are not the free electrons. It means that out of the valence electrons, few valence electrons are very, very loosely connected to their nucleus. Actually, they don't know with which nucleus they are belongs to. These electrons are called as a free electrons. Means when the electrons jump from conduction band to the valence band to the conduction band, these electrons only we call it a free electrons. But not valence, all valence electrons will jump from valence band to the conduction band. Only few valence electrons will jump at a room temperature from valence band to the conduction band, and once the electrons enter into that conduction band, these electrons are called as a free electrons. Agree? Now, what it is required here to understand this concept, my point is that a conductor material consists of large number of free electrons so that a current can easily flow through the conductor. Agree? Insulator does not consist of a free electrons so that it will not conduct at all any current here. Agree? For example, paper, rubber, wood, plastic. And the semiconductor, it shows the property of a conductor as well as insulator. It means that the semiconductor consists of a very few free electrons so that it shows a very little current conduction capacity. Agree? Now, here we consider that one copper wire, a copper is a conductor, and when I say that it is a conductor, so definitely large number of free electrons are available. Do you agree with me? Yes or no? So these are the free electrons which are present in a large order. Now, when we consider a copper wire simply, is the current will flow through that wire? फक्त कॉपर वायर घेतली, ही कॉपर वायर आहे असं अज्युम करा. फक्त कॉपर वायर घेतली तर करंट फ्लो होतो का याच्यातून? देन व्हॉट इज रिक्वायर्ड टू फ्लो द करंट? इट्स अ पोटेन्शियल डिफरन्स. व्हॉट इज रिक्वायर्ड? आता जर मी या एंडला +5 व्होल्ट अप्लाय केलं आणि दुसऱ्या एंडला पण +5 व्होल्ट अप्लाय केलं तर इलेक्ट्रॉनची मूवमेंट होऊ शकते का? No. Is it right? Because here at the two end of this copper wire having its equal potential, so that there is a no movement of a free electrons, and when there is a no movement of a free electrons, no current will flow through that wire. Then what is required? A potential difference. It means that in place of +5 volt, if I try to apply -5 volt here, now can that free electrons can move from one point to another point? Of course, yes, because here the two end of a copper wire having a different electric potential, so that electrons are always move from negative end to the positive end. So this is the direction of a free electrons. And how we can apply that the different electric potential at the two end of a copper wire? So for that, it is necessary to connect the external energy source. So this is the external energy source. This is the actual symbol. In the symbol, if you observe that the bigger line which represents the positive terminal of external energy source and the smaller line represents the negative terminal of external energy source, we say that it's an applied voltage V. So the positive terminal of the external battery is connected to the one end of a copper wire. So this terminal, it acts as a positive terminal or the positive potential terminal. A negative terminal of external battery is connected to the another end of a copper wire. It is considered as a negative potential terminal. And because of the potential differences exist, we know that this end, it acts as a negative terminal. This end, it acts as a positive terminal, so that electron is always moved from negative terminal towards the positive terminal, so that the current, it can start its a journey always from positive terminal of an external battery through the copper wire, exactly opposite to the direction of a flow of free electrons, and the same current will return to the negative terminal. So this is the conventional direction of a current. That's why we always say that the current always flow from positive terminal of a battery to the negative terminal of a battery through external circuit. Is this point is clear? Is this point is clear? Yes or no? Any confusion? Okay. If not, now try to focus on the free electrons. आता एका free electrons वरती focus करा. Let's consider that this is a one free electron. We know that when we apply that external energy source, these free electrons will move from negative end to the positive end. परंतु ज्यावेळेस हा फ्री इलेक्ट्रॉन्स निगेटिव्ह एंड कडून पॉझिटिव्ह एंड कडे मूव्ह होत असेल, त्यावेळेस त्याला त्या मटेरियल कडून काहीतरी अपोजिशन, काहीतरी ऑब्स्टॅकल असेल का नसेल? डेफिनेटली असेल. मग ते अपोजिशन काय असेल? दुसरा मॉलिक्यूल असेल, दुसरा ऍटम असेल, दुसरा फ्री इलेक्ट्रॉन असेल. डेफिनेटली these free electrons will experience the obstacle during their travel, and this obstacle, this opposition to the flow of a free electron, it is called in an electrical language, which is nothing but what? Resistance. And that's why we call the resistance is nothing but what? Now this resistance, which we call it's a opposition to what? तो कशाला अपोजिशन आहे? इट्स अ फ्लो ऑफ फ्री इलेक्ट्रॉन्स म्हणायचं. आता काय म्हणायचं? फ्लो ऑफ, and the flow of free electrons is nothing but the current. That's why we say that it is opposition to the current. The resistance is nothing but the opposition to the movement of a free electrons, and the movement of a free electrons we call it is nothing but the current, means we say that it is the opposition to direct current is there. But here let me explain that the opposition offered by the copper material, it is the property of a copper material. आता या कॉपर मटेरियलच्या ऐवजी जर मी गोल्ड मटेरियल घेतलं तर, किंवा मी सिल्वर मटेरियल घेतलं तर, गेट इट माय पॉइंट, तर त्या ठिकाणी त्यांचा रेजिस्टन्स वेगळा असेल का एकच असेल? 100% वेगळा असेल. लक्षात येतंय का? म्हणजे एखादा पॉइंट जर मी तुमच्या समोर ठेवला तर त्या पॉइंटला अपोज करणारे तुम्ही सगळेजण वेगवेगळे आहेत. तुम्ही म्हणजे सगळे मटेरियल आहेत, एक कॉपर असेल, एक गोल्ड असेल, एक सिल्वर असेल, बरोबर आहे. परंतु प्रत्येकाची त्या पॉइंटला अपोज करण्याची जी काही टेंडन्सी आहे ती वेगवेगळी आहे. सो दॅट्स वाय वी से दॅट द रेजिस्टन्स इज द प्रॉपर्टी ऑफ अ मटेरियल. कोणती वायर वापरली, जर कॉपर वापरली तर त्याचा रेजिस्टन्स वेगळा आहे, सिल्वर वापरला तर त्याचा रेजिस्टन्स वेगळा आहे, गोल्ड वापरला किंवा कोणताही कंडक्टर मटेरियल वापरला, the resistance offered by the material is a different material to material. That is my point. Get it my point? And now you have to give the more focus on these are three words. Number one, now what is this V? It's an external energy source, we call it's a voltage. Number two, when we apply the voltage, a current can flow through the material, that we call it a current. And number three, the opposition to the flow of current, that we call it a resistance. These are the three basic parameters of every electrical and electronic circuit or concept. This voltage we can represent with a V, current I, resistance R. And as I say that these are the fundamental of every electrical and electronic circuit, and to find the relation between these three main parameters, so many experiments are carried out, but at the one time one scientist had discovered the relationship between these three parameters, and the name of that scientist is the Oersted, or we call it Ohm. The name of the scientist is what? Ohm. And the relation between these three parameters we know as a Ohm's law. त्याच्याच नावाने ओळखला गेला बघा. मग ओहम्स लॉ काय आहे ते समजून घेण्याच्या अगोदर तो कशासाठी बनला गेलेला आहे ते समजणं फार गरजेचं आहे. As I say that the applied voltage, a current and the resistance, these are the three basic parameters of every electrical and that electronic circuit. So to find out the relationship between V, I, R, that Oersted, that Ohms has given that the one law, and that is called as a Ohm's law is that. Then what that Ohm's law gives us? काय त्याचा statement आहे? What is the statement of that Ohm's law? Just try to remember that, because this is not the new part. What is that Ohm's law? I think मला वाटतं तुम्ही हे इक्वेशन बघितलं असेल. What is this V? It's applied voltage, I is the current, and R is the, then what is the definition? Can I write this Ohm's law in this way? See that V upon I, which is equal to R. Can I write like that? Can I write like that once again? V upon I is equal to constant. Can I write like that? Yes or no? Because R is constant. Is it right? And with this help of this equation, you can easily write the statement for that Ohm's law. So what is this V? Is the electric potential applied at the two ends of a wire. What is this I? Due to this electric potential difference, a current can flow through it, and which is equal to what? Constant. बघा आता डेफिनेशन कशी लक्षात ठेवायची ती. The ratio of हे काय आहे? V upon I काय आहे? Ratio. The ratio of a potential difference applied at the two end of a conductor. तो कुठं अप्लाय केलाय? दोन एंडला केलाय का नाही? The ratio of potential difference means V. The ratio of potential difference applied between the two end of a conductor to the, आता काय आहे डिनॉमिनेटरला? Current. Current flowing through the conductor is always constant, provided that physical state of a conductor should not be changed. लक्षात राहिली डेफिनेशन? Once again I will repeat. तुम्ही सुद्धा म्हणू शकता. बघा किती सिंपल आहे डेफिनेशन. कारण भरपूर वेळेस मला माहित आहे तुम्हाला ओम्स लॉचं इक्वेशन माहित आहे. इक्वेशन तुम्ही लिहू शकता, पण स्टेटमेंट लिहा म्हणलं तर तिथं कन्फ्युजन होण्याचे चान्सेस आहेत. लक्षात येते का? तर ते स्टेटमेंट कसं लक्षात ठेवायचं? तर हा जो काय मी फॉर्म्युला इथं लिहिलेला आहे, हा फॉर्म्युला पहिल्यांदा तुम्हाला माहित आहे, तर त्याच्यावरून स्टेटमेंट लक्षात ठेवा. आता तर त्याच्यामध्ये पहिला जो काही रेशो आहे तो V बाय I, तो आपल्याला वर्ड्स मध्ये मांडायचा आहे. तर तो मी कसा मांडतोय? द रेशो ऑफ पोटेन्शियल डिफरन्स अप्लाइड at the two end of a conductor to the current flowing through the conductor is always a constant, provided that physical state of a conductor should not be. That's why we can write V upon I is equal to constant, and this constant is nothing but what? Physical state of a conductor म्हणजे काय? की त्याची लेंथ चेंज झाली नाही पाहिजे, त्याचा एरिया ऑफ क्रॉस सेक्शन चेंज झाला नाही पाहिजे, त्याचं टेम्परेचर चेंज झालं नाही पाहिजे, and that constant is nothing but the resistance of that conductor, so that our formula it becomes V is equal to I into R. And this is the very important equation in electrical engineering. V is equal to I into R. This one equation. Is it right? So now please try to remember. आता तुम्हाला ओम्स लॉ हा कशासाठी मांडला गेलाय आणि त्याचं स्टेटमेंट काय आहे, त्याचं मॅथमॅटिकल इक्वेशन काय हे तुमच्या लक्षात आलंय. परंतु प्रश्न इथे येतो की याचे ऍप्लिकेशन्स काय आहेत. What are the applications of Ohm's law? The very simple thing is that you know that the Ohm's law gives the relationship between voltage, current and the resistance. बरोबर आहे. मग आता यापैकी हे तीन गोष्टी तर प्रत्येक सर्किट साठी इसेन्शियल आहेत. इज इट राईट? मग यापैकी एक गोष्ट माहित नसेल तर तुम्ही ओम्स लॉ अप्लाय करून ती कॅल्क्युलेट करू शकता का? दिस इज नथिंग बट द ऍप्लिकेशन. Out of these three parameters, if you don't know any one parameter in the circuit, then by applying the Ohm's law, you can easily calculate the third one parameter. This is the application of Ohm's law. Let me clear that one point. See that. Suppose here I consider that a one circuit. This is a resistance of 10 ohm. This is a applied voltage of 5 volt. Now you have to calculate the current. कसा काढू शकता? तुमच्याकडे ओम्स लॉ आहे, V इज इक्वल टू I इंटू R. V तुम्हाला माहित आहे 5 आहे, I कॅल्क्युलेट करायचा आहे, रेजिस्टन्स माहित आहे 10, so that I is equal to 5 by 10, so that I is equal to 0.5 ampere. This is the application of Ohm's law. आता हे मी तुम्हाला फक्त सिंपल सर्किट सांगितलंय. If you take it any complicated circuit, but if you out of these 3 parameter, if you know that any 2 parameter, the third parameter you can calculate by using that Ohm's law. That is the simple application of Ohm's law. Is it that clear? Once again, let me give that another one example. Suppose this is a one filament lamp. This is a, or better way you can consider that LED. Is it right? And here we have connected this LED to a 1.5 volt. And the current flowing through that LED is 1 milliampere. So my question is that, can you calculate that resistance of that LED? What you know? Applied voltage, you know that 1.5 volt. What you know? A current flowing through that LED, you know that 1 milliampere. Then what you have to calculate? The resistance of that LED you have to calculate. Apply that Ohm's law. V is equal to IR. V is 1.5 volt. The current is 1 into 10 raised to minus 3 milli म्हणजे माहित आहे ना आता का सांगायला लागतंय आता नाही ना. And what you have to calculate? It's a resistance. So R is equal to 1.5 divided by 1 into 10 raised to minus 3. That is the ohm. ते calculate काय तुम्ही calculator वरती पुन्हा करू शकता. Is it right? So these are the simple application of Ohm's law is there. So please try to remember these things. Okay. Please try to read it. The relationship between that applied voltage V, the current I, and the resistance R in a DC circuit was first discovered by German scientist Georg Simon Ohm. This relationship is called as Ohm's law. Applied voltage, load resistance, and the current are these 3 basic parameters of every DC circuit. This is a DC circuit. You can see that in the diagram. Applied voltage symbol, then load resistance, and through the connecting wires, the current can flow through it. Then what is the statement? The ratio of potential difference, applied voltage V, between the end of a conductor to the current flowing between them is constant, provided that physical condition do not change. V upon I is equal to constant, which is equal to R, where R is the resistance of a conductor between the 2 points considered. It simply means that provided R is a kept constant, I is a directly proportional to the potential difference. म्हणजे if I say that, as we know that our equation for the Ohm's law, which is equal to V is equal to I into R, but when I say that R is always constant, then we can easily say that applied voltage is directly proportional to the current. याचा अर्थ काय होतो? What it indicates? As voltage increases, the current is also increases with a same proportion. मग मी जर असं स्टेटमेंट म्हणलं तर as current increases, the voltage is also increases in same proportion. No, it's wrong. कारण करंट हा कशामुळे फ्लो होतोय? अप्लाइड व्होल्टेज मुळे होतोय. करंट मुळे व्होल्टेज अप्लाइड होत नाही. आपण पोटेन्शियल डिफरन्स V म्हणजे काय सांगताय तिथं? पोटेन्शियल डिफरन्स. आपण पोटेन्शियल डिफरन्स अप्लाइड केलं तरच करंट फ्लो होणार आहे का नाही? बरोबर आहे. सो द स्टेटमेंट इज दॅट ऍज व्होल्टेज इन्क्रीजेस, द करंट इज ऑल्सो इन्क्रीजेस विथ द सेम प्रपोर्शन. पण भरपूर वेळेस आपण अभ्यासच असा करतो, V is directly proportional to I म्हणलं काय, आणि I is directly proportional to V. मॅथमॅटिकली कसं लिहू शकता तुम्ही? मॅथमॅटिकली हे दोन्ही स्टेटमेंट बरोबर आहेत. V is directly proportional to I and I is directly proportional to V. मॅथमॅटिकली बरोबर आहे, परंतु त्याचा टेक्निकल मीनिंग जर लक्षात घ्यायचा झाला तर तो टेक्निकल मिनिंग हा फक्त एकच आहे, and that is nothing but as voltage increases the current is also increases with a same proportion. That is the part is there. Is it that clear? Try to read it. So here one simple DC circuit is given with applied voltage is of 5 volt, resistance of 100 ohm, and we have to calculate its current. So definitely by applying that Ohm's law, we can calculate that the current here. This is the application of Ohm's law is there. But there are certain limitations of Ohm's law also there. म्हणजे प्रत्येक वेळेसच आपला हा जो काय फॉर्म्युला आहे, प्रत्येक वेळेसच आपला हा जो काय फॉर्म्युला आहे ओम्स लॉचा, हा प्रत्येक वेळेसच व्हॅलिड असेल असं नाही. अशा कोणत्या केसेस आहेत की ज्या केसेस मध्ये आपल्याला V is directly proportional to I म्हणू शकत नाही. There are certain cases and these are nothing but the limitations of Ohm's law. So what are these cases? Please try to read here. The Ohm's law is not applicable to unilateral network elements. आता हे युनिलॅटरल नेटवर्क एलिमेंट म्हणजे काय सांगतो बघा. आता शब्द ऐकायला नवीन वाटेल, मे बी तुम्ही रीड केला असाल, परंतु युनिलॅटरल एलिमेंट्स म्हणजे काय की असे जे इलेक्ट्रॉनिक्स कॉम्पोनंट जे फक्त एकाच डायरेक्शन मध्ये करंट फ्लो होऊ देतात. मग ते असे कोणते कॉम्पोनंट आहेत तर तुम्हाला माहित असेल डायोड. डायोड मधून फक्त एकाच डायरेक्शन मध्ये करंट फ्लो होतो. मग दुसऱ्या डायरेक्शन जर आपण व्होल्टेज अप्लाय केलं तर करंट फ्लो होत, म्हणजे दुसऱ्या डायरेक्शन मध्ये जर आपण व्होल्टेज अप्लाय केलं तर करंट इज नॉट इन प्रपोर्शन विथ द करंट, सॉरी व्होल्टेज इज नॉट प्रपोर्शन विथ द करंट. त्याच्यामुळे आपण त्या ठिकाणी ओम्स लॉ अप्लाय करू शकत. मग असे जे इक्विपमेंट किंवा असे जे एलिमेंट्स जर सर्किट मध्ये असतील की जे एलिमेंट्स करंट एकाच डायरेक्शन मध्ये फ्लो करतात, अशा एलिमेंटला आपण ओम्स लॉ अप्लाय करू शकत नाही. दॅट इज द फर्स्ट लिमिटेशन. देन सेकंड, आता त्याचं एक्झाम्पलच द्यायचं झालं तर मी तुम्हाला असं दाखवतो बघा. बघितलाय डायोडचा सिम्बॉल असा, तर त्याचा जो काही ग्राफ आहे हा ग्राफ स्ट्रेट लाईन आहे का? स्ट्रेट लाईन म्हणजे काय माहिती आहे तुम्हाला? A straight line is nothing but a straight line which are passing through origin. परंतु इथं तुम्हाला दिसतंय का तसं ते? No. That's why this is a unilateral electrical element and we cannot apply that Ohm's law to this such kind of devices, such kind of elements. This is the first limitation. Now let me go back. Okay. So this is the first limitation. Now try to read the second one limitation. Ohm's law is not applicable to non-linear elements. आता non-linear elements म्हणजे काय पहिल्यांदा लक्षात घ्या. The non-linear elements are those which do not have the current exactly proportional to that applied voltage. आता आपल्याला Ohm's law काय सांगतो की applied the current is always in a proportion with the voltage. परंतु तेच जर proportion मध्ये नसेल तर we cannot apply that Ohm's law. आणि ते कोणते टाइपचे डिव्हाइसेस आहेत? That is nothing but the transistor. लक्षात येतंय? So in terms of the transistor, the voltage and current are not in a proportion, so that we cannot apply the Ohm's law for such component also. You can see that this is the transistor. बघितलाय symbol? Common base, common emitter, common collector, 3 terminal वाला component. Is it right? So for such component we cannot do like that. Okay. And the last one, there are some conductors. म्हणजे असे काही कंडक्टर्स आहेत किंवा सेमी कंडक्टर ज्याला म्हणूया, they cannot obey the Ohm's law because they are non-ohmic conductors. म्हणजे काय की त्यांचा रेजिस्टन्स हा दुसऱ्या कुठल्या तरी पॅरामीटर, आपल्याला माहित आहे की आपल्याला जर Ohm's law अप्लाय करायचा असेल तर हा जो काय Ohm's law आहे याच्यामध्ये R काय पाहिजे हो आपल्याला? कॉन्स्टंट पाहिजे. पण R जर कॉन्स्टंट नाही राहिला तर definitely the voltage and the current they are not in a proportion. And for the semiconductors, R is not constant. R is depends upon the temperature. And so that we cannot apply the Ohm's law to such devices also. These are the three limitations of Ohm's law is there. बघा एकदा सगळे limitations एकदा वाचून घ्या. So let me try to read along with you. The Ohm's law is not applicable for unilateral electrical element like a diode, as they allow the current to flow through in a one direction only. Second, Ohm's law is also not applicable for non-linear elements. Non-linear elements are those which do not have the current exactly proportional to that applied voltage. That means the resistance values of those elements changes for different values of voltage and current. For example, transistor. And third one, it is not necessary that all conductors obey the Ohm's law. There are semiconductors like silicon, germanium, which do not obey the Ohm's law, as they are known as a non-ohmic resistance. म्हणजे त्यांचा काय होतोय change? Resistance change होतोय. That is the point. Is it that clear? So this is about that Ohm's law, the first fundamental and the basic law in that electrical and that electronic circuit. So let me try to revise the concept. बघा आपण आतापर्यंत काय बघितलं. So here we discussed that the first point is nothing but the current. In that we discussed that DC current as well as AC current. Second point, we discuss about that the Ohm's law. As we know that the Ohm's law gives the relationship between the three parameters. Which are these three parameters? Potential difference, electric current, and the resistance. And here we got the definition, V is equal to I into R. I can also write V divided by I is equal to R. I can also write V divided by I is equal to constant. And with the help of this, we can prepare the definition of Ohm's law. But it is, remember that the ratio of voltage divided by current is always constant when the physical state of a conductor should not be changed. Is it right? And then third thing, we discussed that the application of Ohm's law, which is nothing but out of these three parameters, if one of the parameter is unknown, then by using that Ohm's law, we can calculate the third one parameter. Then fourth one, we discussed that the limitations of Ohm's law. Is that point clear? Now please try to consider here the next part. So see that electrical conductivity of a conductor. आता इथं मी एक कंडक्टरचा पीस घेतलेला आहे. So this is the conductor. Here this conductor is connected to that external energy source. So this is that external energy source. If you see that this external energy source, a bigger line indicates that the positive terminal and the smaller line indicates the negative terminal. So this pink color दिसतोय? The pink color, which is nothing but the movement of a free electrons. त्याच्यापूर्वी बघा इलेक्ट्रॉन्स कुठून कसे मूव्ह होतात ते दाखवले गेले बघा. Is it right? The pink color, it indicates that the electrons are moved from negative terminal towards the positive terminal, so that the electric current will flow from positive terminal towards the negative terminal. So this is the direction of a electric current. So that henceforth, please try to remember the one line related to that electric current. The electric current is always flow from positive terminal of an external battery towards the negative terminal of an external battery through external circuit. लक्षात येते? So this is the direction of a current. The free electrons flows from negative towards the positive end. During its travel, free electron faces opposition from another atom and that molecules. During its travel, free electrons collide with another atom, but it completes its path from negative to positive end. opposition offered to the free electrons is the property of a substance. Okay, this opposition is known as what? The resistance of a substance is there. Now, just concentrate towards that word resistance. आता ज्यावेळेस आपण एक पीस घेतलेला आहे, याला ज्यावेळेस आपण एक्सटर्नल एनर्जी सोर्स कनेक्ट केलाय, त्यावेळेस इलेक्ट्रॉन्स कुठून कसा मूव्ह होतोय? निगेटिव्ह टर्मिनल पासून पॉझिटिव्ह टर्मिनल कडे, आणि त्याच्यामुळे आपला कन्व्हेन्शनल डायरेक्शन ऑफ करंट कसा सांगतोय आपण? पॉझिटिव्ह टर्मिनल टू द निगेटिव्ह टर्मिनल. आता फक्त फोकस करा फ्री इलेक्ट्रॉन्स वरती, फक्त फोकस करा. आता ज्यावेळेस आपण म्हणतोय की फ्री इलेक्ट्रॉन्स हा निगेटिव्ह एंड कडून पॉझिटिव्ह एंड कडे मूव्ह होतोय, ते मूव्ह होत असताना त्याला काहीतरी ऑब्स्टॅकल असणार आहे, आणि त्या ऑब्स्टॅकलला आपण काय म्हणणार आहोत? रेजिस्टन्स म्हणणार आहोत. मग हा जो काय या फ्री इलेक्ट्रॉन्स ना एक्सपिरियन्स केलेला जो काय ऑब्स्टॅकल आहे, जो ऑपोजिशन आहे, हा कशावरती डिपेंड्स आहे? What are the factors on which the resistance of a conductor materials are depend? So there are 4 factors are there. Let me tell you what are these 4 factors. Number 1, length of the conductor material. What? Length of the conductor material. Number 2, area of cross section. Area of cross section म्हणजे काय हो? हे बघा हा, बरोबर आहे. नंबर 3, टाइप ऑफ अ मटेरियल. and number 4, टेम्परेचर ऑफ अ कंडक्टर मटेरियल. बघा हे 4 फॅक्टर्स आहेत. What are the different factors on which the resistance is depends? Number 1 is length, number 2 is area of cross section, number 3 is a type of a material, and number 4 is a Now let's we consider that the first factor, which is nothing but length of conductor. आता काय रिलेशन असेल? ही जी काय आहे लेंथ, हे बघा ही लेंथ, या एंड पासून ह्या एंड पर्यंतची लेंथ. हा लेंथ आणि त्याचा रेजिस्टन्स काय 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 त्याच्यामध्ये रिलेशन असेल? एक एक्झाम्पल देऊन सांगतो. आन्सर मला तुमच्याकडूनच हवंय. एक्झाम्पल सांगतो. जस्ट अज्युम दॅट मी एक फ्री इलेक्ट्रॉन्स आहे. अज्युम करा मी पंढरपूरच्या स्टँड वरती उभा आहे, मला जायचंय सोलापूरला. एकच रोड आहे. मग मला ज्यावेळेस सोलापूरला जायचं असेल तर एक फिक्स लेंथ आहे, म्हणजे ती एल झाली. मग मी ज्यावेळेस ऍज अ फ्री इलेक्ट्रॉन म्हणून पंढरपूर कडून सोलापूरकडे मूव्ह होतोय, मध्ये ऑब्स्टॅकल असणार आहेत का नसणार आहेत? म्हणजे तो काय झाला? ऑब्स्टॅकल आहे म्हणजे तो काय झाला? मला होणारा रेजिस्टन्स झाला. कुठला? पंढरपूर ते सोलापूर रोडचा रेजिस्टन्स. आता ते जर मी सोलापूर पासून पुन्हा 50 किलोमीटर पुढे चाललो, म्हणजे माझी लेंथ वाढली, ऑब्स्टॅकल वाढेल का कमी होईल? दिस इज द रिलेशन. लेंथ वाढली, ऑब्स्टॅकल वाढला. ऑब्स्टॅकल वाढला म्हणजे काय वाढला? रेजिस्टन्स वाढला. दॅट इज माय पॉइंट इज दॅट it means that as the length of the conductor material increases, the resistance is also increases, so that the relation between the length of the conductor material and the resistance is a directly proportion. परंतु ते म्हणत असताना टेक्निकली एक वाक्य लक्षात घ्या. व्हॉट इज द करेक्ट स्टेटमेंट इज दॅट as the length of the conductor material increases, the resistance is also increases with the same proportion. This statement is correct. But if you say that as the resistance increases, the length is also increases, that is wrong. म्हणजे लेंथ वाढला तर रेजिस्टन्स वाढतोय हे बरोबर आहे, परंतु रेजिस्टन्स वाढला म्हणजे लेंथ वाढलीच पाहिजे हे चुकीचं आहे. डू यू एग्री विथ मी? लक्षात आलं कसं रिलेशन आलं ते? नेक्स्ट टेक दॅट द सेकंड पॅरामीटर विच इज नथिंग बट एरिया ऑफ क्रॉस सेक्शन. आता याचा पण आन्सर तुम्हीच देणार आहे मला. त्याला आपण म्हणतोय ए. नाउ प्लीज रिमेंबर दॅट आता मला पंढरपूर स्टेशन पासून सोलापूरच्या स्टेशनला जाताना एकच रोड आहे, बरोबर आहे, परंतु त्या रोडला मला अपोजिशन पण होतोय. आता एरिया ऑफ क्रॉस सेक्शन वाढवायचा आहे, म्हणजे जर मी तो रोड ब्रॉडर केला, अजून त्याचा एरिया ऑफ क्रॉस सेक्शन वाढवला, 4 पदरी केला, माझा ऑब्स्टॅकल कमी होईल का वाढेल? काय होईल? बरोबर आहे का? एरिया ऑफ क्रॉस सेक्शन वाढला तर माझा ऑब्स्टॅकल, मला होणारा ऑब्स्टॅकल कमी झालाच पाहिजे, म्हणून तर 4 पदरी 4 लेन तयार करतोय आता सध्या. मग जर एरिया क्रॉस सेक्शन वाढला तर रेजिस्टन्स कमी होतोय, तर याचा अर्थ त्याच्यामध्ये काय रिलेशन आहे? दॅट इज माय पॉइंट इज दॅट सो रेजिस्टन्स इज इनव्हर्सली प्रोपोर्शनल टू द एरिया ऑफ क्रॉस सेक्शन. लक्षात येतंय सगळ्यांच्या? नाव द थर्ड पॉइंट, that is nothing but type of material. The type of material is nothing but the availability of free electrons in the material. आता जर आपण कॉपर मटेरियल घेतलं तर त्याच्यामध्ये असणारे फ्री इलेक्ट्रॉन्स वेगळे आहेत. गोल्ड मटेरियल घेतलं तर त्याच्यामध्ये अवेलेबल असणारे फ्री इलेक्ट्रॉन्स वेगळे आहेत. सिल्वर मटेरियल घेतलं तर त्याच्यामध्ये असणारे फ्री इलेक्ट्रॉन्स वेगळे आहेत. डू यू एग्री विथ मी? का सगळ्या कंडक्टर मध्ये फ्री इलेक्ट्रॉन्स सेम असतात? नो, दॅट इज माय पॉइंट. म्हणजे प्रत्येक कंडक्टरचा मटेरियल चेंज केलं तर डेफिनेटली फ्री इलेक्ट्रॉन्स हे काय होणार आहेत? आता मला सांगा, करंट कॅरी कोण करतोय? करंट कॅरी कोण करतोय? फ्री इलेक्ट्रॉन्स कॅरी करतोय. मग एखाद्या मटेरियल मध्ये जर जास्त फ्री इलेक्ट्रॉन्स असतील तर त्याची करंट कंडक्शन कॅपॅसिटी काय असणार आहे? म्हणजे नंबर ऑफ फ्री इलेक्ट्रॉन्स मोर, द लार्ज अमाउंट ऑफ करंट कॅन फ्लो थ्रू इट, म्हणून तर आपण त्याला कंडक्टर म्हणतो. मग तसंच इन्सुलेटर मध्ये फ्री इलेक्ट्रॉन्स आहेत का? म्हणून करंट काय झालाय? 0 झालाय, बरोबर आहे का? आता कंडक्टर मध्ये वेगवेगळ्या मटेरियल मध्ये असणारे फ्री इलेक्ट्रॉन्स हे डिफरंट आहेत. मग व्हेन आय से दॅट the material, if the material consists of large number of free electrons, a large amount of current can flow through it. Do you agree with my statement? आता ज्यावेळेस आपण म्हणतोय की जास्त फ्री इलेक्ट्रॉन्स आहेत म्हणून त्याच्यामध्ये जास्त करंट फ्लो होतोय, मग जास्त करंट फ्लो होतोय तर त्याचा रेजिस्टन्स काय पाहिजे? कारण रेजिस्टन्स काय आहे? एक्झॅक्टली अपोजिट टू द करंट. म्हणजे रेजिस्टन्स काय पाहिजे? हा, म्हणजे एक पॉइंट लक्षात घ्या की जर मटेरियल मध्ये जर फ्री इलेक्ट्रॉन्स हे जास्त प्रमाणात असतील तर त्याचा अपोजिशन काय असणार आहे? कारण त्यातून फ्लो होणारा करंट पण काय असणार आहे? जास्त असणार आहे, म्हणून त्याचा रेजिस्टन्स काय असणार आहे? कमी असणार आहे. दॅट इज माय पॉइंट इज दॅट इट मीन्स दॅट इफ द मटेरियल कन्सिस्ट ऑफ लार्ज नंबर ऑफ फ्री इलेक्ट्रॉन्स, आता मी इथं वाक्य लिहितोय, बघा हे वाक्य लक्षात येतंय का? इफ द मटेरियल कन्सिस्ट ऑफ लार्ज नंबर ऑफ फ्री इलेक्ट्रॉन्स, मग आता इथं लार्ज नंबर मी हा अपवर्ड एरोने दाखवतोय, तर त्यातून फ्लो होणारा करंट सुद्धा जास्त असणार आहे. मग करंट जास्त आहे म्हणजे रेजिस्टन्स आपण काय म्हणणार? काय म्हणणार? डेफिनेटली इट्स लेस. हा डाऊनवर्ड एरो दाखवतो. लक्षात येतंय? अपवर्ड एरो डाऊनवर्ड एरो. ओके, आता ह्या वाक्यावरती स्टिकअप राहावा, कारण पुढे जाऊन मी तुम्हाला कन्फ्यूज करणार आहे मुद्दाम म्हणून. तर तुम्ही कन्फ्यूज व्हायचं नाही, मी आताच तुम्हाला अलर्ट करतोय. What I say that the type of material is nothing but the number of free electrons available in that material. If the large number of free electrons are available in that material, it offers the less resistance. Do you agree with me? Now, the next point is a temperature. Now try to understand what is the effect of temperature on the resistance. आता ज्यावेळेस आपण मटेरियलचं टेम्परेचर वाढवणार आहोत, म्हणजे त्या मटेरियलला काय देणार आहोत? टेम्परेचर देणार आहोत, काहीतरी एनर्जी देणार आहोत. डेफिनेटली ड्यू टू इन्क्रीज इन टेम्परेचर, the covalent bonds in that material atoms are try to break, and that electrons are try to move from valence band to the conduction band, so that number of free electrons are goes on increasing. म्हणजे टेम्परेचर वाढवलं तर फ्री इलेक्ट्रॉन्स काय होत आहे? वाढतायत का कमी होत आहेत? इट विल बी इनक्रीजेस. आता नंबर ऑफ फ्री इलेक्ट्रॉन्स इन्क्रीजेस झाले तर रेजिस्टन्स काय होईल? दॅट इज माय पॉइंट. दॅट इज माय पॉइंट. मी फक्त तुम्हाला टेम्परेचरचं आणि फ्री इलेक्ट्रॉनचं रिलेशन सांगितलंय. मी रेजिस्टन्सचं रिलेशन सांगितलं नाही अजून. When we are going to increase the temperature of a conductor, the number of free electrons are going to be increases. Now I want that answer from your side. If the number of free electrons are going to be increases, what is the resistance of that material? It is wrong. आता तुम्ही म्हणताल की सर पहिल्या स्टेटमेंटला तर तुम्ही ते सांगितले, आता कसं काय रॉंग म्हणताय? So have you ever learned one concept in the physics, and that concept is nothing but concept ऐकलाय, वाचलाय? म्हणजे काय? The thermal vibration means when we are going to increase the temperature of a conductor materials, all the molecule structures are start to vibrate. म्हणजे इथून पंढरपूरहून सोलापूरला जात असताना प्रत्येक ठिकाणचे पॉइंट्स हे व्हायब्रेट होऊ लागले, तर मला होणारा ऑब्स्टॅकल वाढेल का कमी होईल? मग रेजिस्टन्स कमी कसा होईल म्हणताय? ऑब्स्टॅकल वाढला म्हणजे रेजिस्टन्स काय वाढला? रेजिस्टन्सच वाढला ना. So that is the point. And please try to remember that though as we increase the temperature, though the number of free electrons increases, then also the resistance is also be increases. This is the effect of temperature on that resistance. लक्षात राहिले 4 parameters. And now with this discussion, now we are trying to calculate that one mathematical formula for resistance. And how I can try to calculate? Please try to observe here. So with this 4 parameter, I can write resistance of a conductor material is directly proportional to the length and is inversely proportional to the. थांबा, गाय करायची नाही. जोपर्यंत मी थांबत नाही तोपर्यंत गाय करायची नाही. मला वाटतं लास्ट वॉर्निंग असेल, नाहीतर पुढे येऊन एक्सप्लेन करायला लावणार आहे बघा. कुठलं परवडतंय बघा. When I say that R is equal to L upon A, means resistance is directly proportional to the length and inversely proportional to the area of cross section. What is this? हे काय? It's a proportional sign. When I want to replace this proportional sign with a proportional constant, I can replace with R is equal to rho L by A. This is a formula for the resistance of a material, where rho is the proportional constant. तुम्ही पुढच्या लेक्चरला येताना how you define that the rho, what is the formula for the rho, what is the unit of the rho, please study it. And then here we can stop here. Thank you very much.